So, this is pre-calculus, what I'm in right now.
Okay.
So we're doing stuff with quadratic functions.
Okay.
And
This a pre-calc trig class, so that you'll be taking trig next semester, or?
I think it's just supposed to be pre-calc the entire year, but I'm not sure.
Okay.
But the type of, I have a test tomorrow, and we have a match tonight, so I won't get home till late. So I just have a little bit of time here right now. So the type of problem I'm confused about, I think it's called a revenue problem.
Okay.
Like, for example, like this doesn't have to be the one that we do, but this is just the first one I see on this piece of paper. It says like, John has a pig that weighs 200 pounds. He could sell it for a price of $1.40 per pound. The pig is gaining 5 pounds per week, and its price is dropping 2 cents per week. Write an equation for the total worth of the pig. And then like part B is, when will the pig have a value of 0? And then part C is like, what is the maximum cost of like the pig like after a certain number of weeks and stuff like that.
Okay. Wow.
So like any problems you can think of like that. I also have like a packet here if you want me to send you one.
Let me think about this for a minute. This is a pretty unusual problem.
Really?
Big ways, well, yeah, I can't say that I've run across this, but that's typical of Kent. So let's see, the pig weighs 200 pounds, it's gaining 5 pounds per week. You can sell it for $1.40 per pound, but it's losing 2 cents per week. Well, it's pretty easy to answer one of those questions, which is, when will the pig have a 0 value? When would that be?
Would that be just like before it's born or something?
Well, if it's dropping in value by 2 cents per week, then it's got 70 weeks. In other words, I'm going to divide $1.40 by 2, or 140, because it's 140 cents divided by 2 cents. So in 70 weeks' time, the pig won't have any value. Not quite sure why that's the case. Maybe that's the way that market works. Because it's going to weigh 550 pounds in 70 weeks, gaining 5 pounds a week. Oh no, I didn't do the math right there. Gaining 5 pounds per week times 70, yeah, that's 350. So it'll weigh 550 pounds. Now, I'm not sure why a 550-pound pig isn't worth anything, but unless I wrote something down here, what was the very first question they asked?
It said, so write an equation for the total worth of the pig as a function of weeks.
Okay. So there, right there, they give you a clue as to how to start the word problem. The way every word problem really needs to be started is to define the variable, okay, or variables. And in this case, there really is only one variable, and they give it to you in that last sentence. And that's always where to go, is the last sentence is a good place to start looking to how to define your variable. So if I let x equal the number of weeks, so the value of the pig, I'll use a capital V, equals, what should it be? It's not that unusual a problem. Now that I look at it, it's pretty standard. I don't know why it made me think it was unusual when I first looked at it.
Okay.
So what's the starting value of the pig? Oh, hold on. Hold on a second. The first question says, write an equation for the value of the pig or the weight? Oh, the value of the pig.
Yeah, it says write an equation for the total width of the pig as a function of weeks.
Okay. What's the value of the pig to start?
The value of the pig to start is 200 times $1.40.
Correct. Plus what? We're going to have a plus something and we're going to have a minus something, because the value of the pig is going up as X increases by
So
how
then
much?
is it plus, do we need an X in here somewhere?
Yes, for sure.
Okay.
Okay. So after 1 week, how much does the pig weigh?
It's going to weigh 205 pounds.
And it will have gained how much in value?
It will drop 2 cents.
It gains because it's gaining 5 pounds and you're selling it for $1.40 a pound.
Okay.
So it's going to gain from this part 7x.
Right.
And then it's going to lose from this part how much?
2 cents. 0.2x? Wait.
Now let's see. If I've made this, I've made everything in dollars. So we have to put this in dollars. So it would be 0.02x.
Okay.
Okay. I could have put everything in cents. Then this has become 700x instead of 7x. And this would become 140 here. But it's easier actually to work in dollars. So there's the equation. Actually, my very first statement, I'm not sure. Hold on a minute. Let me think about this. I don't have this quite right. It goes up by 7x, $7 per week.
Right.
Based on the weight gain. And it goes down by 2 cents per pound per week.
So
it's really dropping by what? It's dropping by 10 cents per week.
2 cents per pound. And if it drops by,
well,
right,
it goes up by 5 pounds.
Right.
And you don't get $1.40 per pound of that gain, because in that week's time, it's no longer worth $1.40 a pound. It's worth $1.38 per pound. So, let me think about this. So the starting value is not really 200. Let's start from scratch here.
All right.
Starting value is definitely that times that. Now, do I want to make it gaining and losing? That's going to be hard to figure out the equation for that. Maybe
that's where I get confused.
Yeah, better off putting. Let's see if we can come up with a formula. Let me think for a second. So let's see. The value is the weight of the pig times the price per pound. Correct? Always?
Correct.
Well, what's the weight of the pig? The weight of the pig is 200 plus 5x. That is the weight of the pig, always,
Yep.
at any point in time. The price per pound is $1.40 minus 0.02x. Perfect. Because now when x is 0, the value of the pig is 200 times $1.40. When x is 1, we would have a 205-pound pig, and we would have a value of that pig of $1.38 per pound. We got it right.
Yep, that worked out.
The secret for me was to put it in words. The value of the pig is always its weight times its current price per pound. And then you just have to figure out expressions that represent each of those and put parentheses around.
So if you kind of just like look at it and try to write it out, then you can kind of plug those numbers in. That makes sense.
Well, yeah. In other words, by writing it out in words and then figuring out what the weight was as a mathematical expression and what the price per pound is as a mathematical expression, notice that when we multiply these two things together, we're going to have an x squared term. So, and we should be looking for that. In other words, the subject material is quadratics. So we would expect to come up with something that had an x squared term. Okay, so that's the expression for part A, and that's the hard part. The rest of it should be relatively easy.
It seems like you just should be able to kind of plug in numbers to find
I think so. What was the second part of the question?
The second part was, when will the pig have a value of 0? And we already got that.
Right, because if this whole thing is 0, well then the product of this and this is 0. This part never becomes 0, but this becomes 0 after 70 weeks. Okay?
And then part C is, what is the Y-intercept of this function, and what is the easiest way to find this?
Okay. Whenever you have a quadratic,
yeah.
If I have a quadratic that's of this form, the y-intercept is always that. Because the y-intercept is where x is equal to 0, by definition. Right?
Yep.
Okay, well, if you set x equal to 0 in this, then this c is always the y-intercept. So in this problem, the easiest way to get the y-intercept, we know where that constant comes from. It comes from multiplying that number by that number. So the y-intercept is 280. In other words, when you multiply a linear term by a linear term, you get a quadratic that's in that form, ax squared plus bx and so forth. And the final term c always comes from the multiplying the number by multiplying the other number.
So pretty much I just, like in any other problem, I would just multiply the two numbers together that do not have an x, and then that's my y-intercept?
You got it.
Sweet. That's an easy trick.
Yeah, it is. Now, notice the other way I could have done this was to go ahead and multiply it out.
Yeah.
Multiplying it out isn't the easiest. Let's see how hard that is to multiply out. It can't be that hard. Let's see, we've got a 0.1x squared. That's a negative in front of it. We got a positive 7x and a minus 4x. So we got plus 3x, and then the two numbers are 280. So there's our function. Okay. And
Okay.
we might need that for one of the other questions on this problem, but it's often beneficial to leave it as two linear factors rather than multiplying it out. Frequently when you're dealing with quadratics and you multiply it out, at some stage you're going to have to factor that. And factoring that back into those two, you don't want to have to do that if you don't have to.
Right.
Were there any other questions on that?
No, that was the end of that problem there.
Okay. Obviously, the tough part on all of these is setting it up, coming up with that first equation. So
Right.
if you want, give me a couple more and we'll do that alone, and then you should be able to take it from there.
Okay, let me see if I can find another one like this. Let's see. Okay, here we go. Here's another one.
Okay.
An orange grower has 400 crates of fruit ready for market and will have 20 more each day they wait. The present price is $60 per crate and will drop an estimated $2 per day for each day waited. How many days should the grower sell her crops in order to maximize her income?
Okay. This is a very similar problem. We're going to do it very similar, only then we're going to have a quadratic that we need to find the optimum. They didn't ask us that on the pig question, did they?
No, they didn't.
Oh, I thought maybe they did, and we just didn't do it. But you would take that quadratic, which is a parabola, and you would figure out where the vertex was.
Because the vertex is going to be
always going to be the
highest point.
In other words, we're going to end up with a quadratic like that. And
right.
At this point right there, whatever that X value is, that represents when you should sell. Because over here is income or revenue. Okay?
And then the vertex is always the highest point of the graph. So that's going to be the highest point of revenue.
That's the way you always find your maximum or minimum. If you're dealing with a parabola that looks like that, then you're going to find a minimum value right there.
Okay.
But when they ask for that value, you really, there's two answers, and that is what's the X value and what is that maximum revenue that you get. So let's set this up. What's first step?
First step is to find the equation.
Set the variables. First step is to define your variables.
Define the variables.
X
so
what?
X is going to be the number of days waited.
Okay. So the value, or the revenue, let's call it, is equal to what? Let's use words.
Okay, so looking back at the pig problem, we had weight. So it's going to be number of crates ready right now?
Well, at any point.
Okay.
If you wait a day, you'll have 420 crates.
Right.
Okay, so it's the number of crates that you have times what?
Number of crates times 20x.
Price, let's use words. Price.
Price
per crate.
Per crate.
In other words, they give you that right up there. That's all the further you have to look. The number of crates times the price per crate gives you the revenue.
Okay.
In terms of X, what is the number of crates?
That's the 400 crates plus 20x.
Correct. And what's the price per crate?
That is going to be, present price is 60 and will drop to, 60 minus 2x.
Correct. Okay. Now, in order, they want to find out when you should sell. Should you sell today, or should you wait some number of days to sell? And the way we're going to figure that out is we're going to graph this quadratic.
Okay.
We're going to find its vertex. Well, I've got it in a form where I can't find the vertex easily. I can find the Y-intercept easily, but
yeah,
the vertex. So let's multiply it out. We got minus 40x squared. See, we got plus 1200x minus 800x, that's plus 400x, plus 24,000. I think it's 1,000, yeah.
Yeah, it is that.
Okay. So now the easiest, if the vertex is the only thing you have to find, I don't need to graph this. In fact, all I need to find is the x-coordinate of the vertex, right?
Right.
That will tell me how many days to wait. Well, what's the simplest way to get the x-coordinate of a vertex?
Set the y equal to 0.
Well, no, that...
Oh, right.
That
Negative...
will give you the X-intercepts.
Yeah, not the...
We actually could get the X-intercepts pretty easily from our two-factored things. In other words, wherever that's equal to 0 or that's equal to 0 are your two X-intercepts.
Right.
But if I'm trying to find the vertex, it's easier. This is the most direct way to get the vertex. And if you forget this, notice what the quadratic equation is. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Bingo, it's the very bottom left fraction.
Oh, so it's, okay.
Okay?
I remember that now. We
talked about it. In fact, if you know one of these, it helps to memorize the other, or if you know the other, it helps to memorize this one. Not everybody is in the habit of using the minus b over 2a. There's about 4 different ways to approach quadratics, and this is just one of them. But I think this is the most direct way of solving for x. And
yeah, it seems like the most simple. So that's just going to be negative 400 over 2 times negative 4. So 80?
Negative 80.
Negative 80.
Yeah, in other words, there'd be a problem if we came up with a negative days, right?
Yeah, it would be good.
No. We know we did something wrong if we come up with a negative number there. So always remember that. Because it's easy to make that mistake you just made, to make that 80 and you come up with a negative 5. So 5 days produces the maximum revenue, and now their next question is going to be, how much is that revenue, right?
Right, I was just going to ask that. So like what, so now we just need to find the, like
so where do I put in the 5? Into which equation?
Just our starting equation?
Probably this one is the easiest math, don't you think?
Yeah.
I could plug it into the quadratic, but gosh, if I plug it into this one, I get 300 times 50, which is a revenue of $15,000.
So is that 15,000, like, is that the y-coordinate of the vertex when the x-coordinate is 5?
In other words, what we're looking at is and I can graph it really easily now that I know the vertex. We know the vertex occurs along this line of symmetry at 5, right? So the only thing I need is what the y value is, and it's 15,000. So if I make that 15,000 right there, Now I can graph that thing. I know it goes down. Now, I don't know what these two exact points are, but they might ask that as part of that question also. They may say, what are the X-intercepts?
Mm-hmm.
And if they do, then you have to go back up and solve this by setting this equal to 0. Again, I find it easier to solve this. In other words, the way you solve these is by factoring them.
Okay.
This one's already factored. We started it with it factored.
Yeah, so that's easy.
That equal, figuring out what makes that 0 would be an x of 20. No, there is no thing that makes that 0. But there is an x of 30 that makes that 0. In other words, at the end of 30 days, price per crate has dropped to 0. And this makes sense. Oranges get worse with time.
Right.
What's wrong with a 550-pound pig? Why would that be worth 0?
Yeah, exactly.
The pig didn't make a whole lot of sense, but this makes very much sense. Yeah, this is a very real-life practical problem that this farmer has to figure out. Now, he may do it by trial and error. He may try one day and see what his revenue is, and then 2, and then 3, and then 4, and then 5, and then 6, and he realizes that 5 is the optimum. But if you want to solve this problem mathematically, this is the way to do it.
Yep. Awesome. Yeah, that makes a ton more sense now.
Yeah, and I think this step right here is probably the most important one.
That's what I was going to say.
It's easy enough to come up with this if you're looking for the number of crates, and this if you're looking for the price per crate.
Because then we can just take the X, which we already defined, plus the number that we have, and then, yeah, it just makes it so much simpler once you see it in words.
The only thing you got to be a little careful about is when they switch units up on you. Now, they didn't do that here. In other words, everything was in dollars. This was dollars, and this was dollars. Whereas in that pig problem, one thing was in dollars and the other was in cents. So be careful. Yeah. Be careful with that when you run into a problem. Got any questions, Casey, or are you good to go?
No, I'm good to go. Oh, thank you so much.
Yeah, you're welcome. Well, good luck on your test, and good
luck
with your tennis this season.
How much do I owe you again? Is it 18?
It's 16.
16. All right, I'll send that in the mail. Yeah, thank you very much. Got some good matches this week, and
good.
I'll probably talk to you before state, which is in, I think it's only like 3 weeks away now. So
okay. Well,
exciting stuff.
Yeah, I bet it is.
Yep.
Where do you play most of these matches? Do you play them at their school or your school, or what about where is state played?
State is played in Pueblo, which is like way down south.
That's too bad. I was going to say, gosh, if it's somewhere close, I might come by and watch some. But
yeah, it's for 5A, it's at Gates Tennis Center, which is just right by Cherry Creek Mall.
Yeah, I know where.
But we're in 4A, so we're all the way down in Pueblo.
Wow.
Yeah.
Well, that's unfortunate.
Yeah, it's a little bit of a drive. And
I'll bet they wish you were in 5A, you being the #1 player in the Intermountain, huh?
Yeah, it would definitely be a little bit more competition, but it's fun. I enjoy high school tennis a lot.
Yeah, well, good.
Yep.
All right, Casey. Good luck. Talk to you later.
All right, thanks. Talk to you later.